Hello, and today we will be learning about the real number system. Make sure your table of contents are filled in. So as you can see, we are adding the real number system on page 13 and 14. Okay, so today we're still in Unit 1. We're going to focus on classifying numbers. Our essential question is, what is the real number system? Remember, if there's anything you're confused about, you're going to write your questions along the left-hand side. And then we're going to get started on our notes for the real number system. You should be roughly around page 13. At any time you need to pause the video to write this down, feel free. Okay, so we are going to start with rational numbers. Okay, rational numbers is a number that can be written in the form of a ratio, okay? We typically think of ratios with the colon, but a ratio is also a fraction. Okay, what kind of numbers does this include? Well, we have terminating decimals. Okay, those are decimals that end. So an example would be like 1 and 25/100ths. We have repeating decimals. Okay, that would be with that line over a number or numbers that show it's repeating. Integers. Okay, so those are the positive and negative numbers. We have whole numbers. Okay, that would just be the positive side of integers. We have natural numbers. Okay, those start at 1. I'm going to just start counting numbers, so 1, 2, 3, and so forth. And then we have what's probably a new term to you, perfect squares. And this can be something that we struggle with a little bit. So really what that is it's represented by a radical or a square root. And perfect squares are numbers that we multiply the same two numbers to get the next one. So 1 would be our first one. So the square root of 1. And then because that's 1 times 1. Then we move to 2 times 2, which is 4. So the square root of 4. These are perfect squares. Then we move to 3 times 3. So that would be the square root of 9. 4 times 4. Square root of 16. 5 times 5. Square root of 25. And hopefully you can see that pattern now. So anything that falls in between so these are the only perfect squares. If it's anything that falls in between, it's not a perfect square. So let's take a look at irrational numbers. So irrational numbers are numbers that cannot be written as a fraction or a ratio. So it's literally the exact opposite. So what would count as an irrational number? Well, if terminating decimals were part of rational numbers, then we would say non-terminating. Decimals are irrational. And non-repeating. Okay, and then we also have non-perfect squares. Okay, if we were to calculate or find one that looked like this, it would be something that would have like 2, 6, 8, 7, 6, 3, and then it might have some dots going on to show that it's continuous. A very famous irrational number that a lot of people know is pi. Okay, because pi is a non-terminating, non-repeating decimal. And then any non-perfect square, so that would be like the square root of 2. Okay, the square root of 3. A number that we don't know another number that can multiply itself to get that number. Okay, so those are non-perfect squares. All right, so as you can see here, this is what we consider to be the real number system graphic organizer. Okay, so everything inside this is real numbers. So all numbers are real numbers. Every number that we're going to go over. What this graphic organizer tells us is that under rational numbers, a natural number is also a whole number, which is also an integer, which is a rational number. So if we work from the inside out, that tells us what type of numbers they are. So all natural numbers are whole numbers, all whole numbers are integers, and all integers are rational numbers. Okay, and then you'll see over here is our irrational numbers. They're in their own separate thing. And then all irrational and rational numbers are real numbers. That's what this graphic organizer tells us. So let's take a look at what natural numbers are. So if you remember earlier, I said they start at 1. So they're just our counting numbers. So 1, 2, 3, 4, and then so on. Okay. Whole numbers, the only difference between whole numbers and natural numbers is that whole numbers start at 0. So 0, 1, 2, 3, 4, 5, and so on. Okay, notice that we have no decimals in those. So integers are the negative. It's all our natural, all our whole, and then we also have the negative. So integers, we'd say like -4, -3, -2, -1, 0, 1, 2, and so forth. Okay, so they include all the natural, all the whole, and then our negative numbers. Okay, integers are not decimals. And then our rational numbers are terminating, repeating, and fractions. So we can have fractions, we can have terminating decimals, or we can have repeating decimals. Okay, so that's where the rational goes. Over under irrational, we have pi, non-perfect squares, so like the square root of 11, or decimals that just constantly go on. Okay. So that's what this is. And you're going to be asked to label and add numbers to these. So please make sure you can recognize this. And if there are questions with this, make sure you ask. All right, so let's practice some. So we want to classify the following as real, irrational, rational, integer, whole number, natural number. So every single number will be real. Okay, so the first thing you should be able to determine is that these are all real numbers. Okay, if I am looking at 0, we'll do 0 together. 0 is not a natural number, but it's a whole number. So we would say this is a whole number. And because it's a whole number, it's also an integer. And then because it's an integer, it's a rational number. And then it's also a real number. So you're going to see that these might be labeled more than one. Okay, you should always have at least two. It should be real and something. And then you have to determine which other ones it is. So you can use our graphic organizer to determine that. So if it falls under a natural number, that means it's also a whole number. It's also an integer, rational, and real. If it's an irrational number, then it's irrational and real. Okay, so use the graphic organizer to help you a little bit with that. So go ahead, pause this video, and see if you can finish. You'll also have to go back to number 1 to finish labeling the rest of these numbers. Okay, hopefully you've taken the time to pause the video and label the rest of the numbers. So let's see how you did. Okay, so as you can see here, I highlighted all of the numbers that are rational in pink and the only number that was irrational in yellow. So we're always probably going to have more rational numbers than irrational numbers. So the first one should have been real and rational. We already did 0. 17 is real, whole, natural, rational, and an integer. That's all of them. Number 4 was our only irrational, and that's also real. Number 5 is real and rational. Number 6 is real, rational, and an integer. Number 7. So number 7 is 81. So 9 times 9 is 81. So that's a perfect square. So that makes it rational. It's also an integer because these could be negative 9 times 9, and then it's real. And then 0 and 7 tenths repeating is rational and real. And then number 9 is also rational and real. Okay. At this time, you are ready to move on to your activity for today. If you have any questions, please make sure they are clarified before you move on.